In section 5.5, we'll be talking about zeros of polynomial functions. The definition states that the remainder theorem, that if a polynomial f of x is divided by x minus k, then the remainder is the value f of k. So how do we do this? Well, given a polynomial function f, we're going to evaluate f of x at x equals k using the remainder theorem. Step 1, we're going to use the synthetic division to divide the polynomial by x minus k. Step 2, then the remainder is the value of f of k. So for example number 1, it's asking us to using the remainder theorem to evaluate the polynomial. When it's asking us to use the remainder theorem to evaluate this function, when we're looking at this function, we have 6x to the fourth minus x cubed minus 15x squared plus 2x minus 7 at x equals 2. So what we do is we're going to take down the coefficients of that entire polynomial, and we're going to place them here. So we have 6, negative 1, negative 15, 2, and then negative 7. And since x is equal to 2, it's the same thing as using synthetic division to divide by the polynomial x minus 2. So here's our 2. First thing we're going to do is we're going to bring down that 6. And so now we take 2 times 6, which is 12. Negative 1 plus 12 is 11. 2 times 11 is 22. 22 plus negative 15 gives you 7. 2 times 7 is 14. 14 plus 2 is 16. 2 times 16 is 32. And 32 minus 7 is 25. So technically what we would have gotten is this polynomial. This would have been then 6x cubed plus 11x squared plus 7x plus 16. And therefore, this is the remainder. And so what it's saying here is that since the remainder is 25, it's when the input is 2, then the remainder is 25. And then we can check our answer by evaluating f of 2. We would plug it back into the function. So if we plug 2 back into the function and evaluate, and using order of operations, then we should also get the same answer, which is 25.